Hi, I'm Papia. In this problem, we have the function g given by t to the 5 minus 6t cubed plus 9t. We have to first find all the zeros of this function g. So how do we find all the zeros? Well, you take your function and set it equal to 0 and solve for t. So those are the points where the graph of the function will touch x-axis or cross x-axis. Okay, so let's see. Take the expression of the function and set it equal to 0. So we'll have t to the 5 minus 6t cubed plus 9t is equal to 0. And then we have to factor. So if you notice, we have a common factor of t from all three terms. So pull it out and you will be left with, from the first term, you will have t to the 4. Second term, you will have negative 6t squared. And third term, you will have plus 9. That is equal to 0. Now you have to factor this expression. Notice that this is t squared square minus 6t squared plus 9. So you factor just like you will factor a quadratic. And note that the factors are going to be t squared minus 3 and t squared minus 3. So check quickly, it's t to the 4 minus 3t squared minus 3t squared, so minus 6t squared plus 9. Okay, now look at this factor. This is t squared minus 3. This is also difference of two squares, so you can factor it further. So this one will be t minus square root of 3 times t plus square root of 3. But there are two of them, so you will get 2 of each of these factors. So you just square them. All right. So each factor will give you a 0 of the function. So the zeros are, the first factor is giving you t equals 0. Second one, t equals square root of 3. And third factor, t equals negative square root of 3. So there are 3 zeros. For part B, we have to determine whether the multiplicity of each 0 is even or odd. Okay, so let's take each 0 and see what is their multiplicity. So if you take t equals 0, go back here and look at the factor that gave you t equals 0. The factor is t, which has a power 1. That means t equals 0 has a multiplicity of 1. And 1 is, of course, odd. All right. Next, let's pick t equals square root of 3. So if you look at this factor again, the t minus square root of 3 has a power 2. Which means this 0, that factor appears twice. So the multiplicity is 2, which means it has an even multiplicity. And the last one, t equals negative square root of 3. Again, notice that the factor is t plus square root of 3 and it appears twice. Since the power is 2, this one also has a multiplicity of 2, which is also even. So we determine the multiplicity of each 0. Finally, we have to determine the maximum possible number of turning points of the graph of the function that's given to us. Well, it depends on the degree of that polynomial. So notice that degree of the function g is 5. And therefore, the maximum number of turning points will be so the number of turning points of the graph of G will be at most the degree minus 1, 5 minus 1, which is 4. So there can be at most, not more than, 4 turning points. Finally, we have to graph this function using a graphing utility and check our results. So let's use a graphing utility. Graph the function x to the 5 minus 6x cubed plus 9x. And notice, first of all, there are 3 zeros, as you can see from the graph. So you can use trace and plug in x equals 0, square root of 3 and negative square root of 3 to check that those are the 3 zeros. And then you can also notice that there are how many peaks does that graph have? How many turning points does the graph have? Well, turning points really means the relative max or relative mean. Notice further that if you look at the graph in the graphing utility, how many turning points does this graph have? Well, you see there is 1, 2, 3, 4 turning points. And we did find that the number of turning points can be at most 4, which is also verified from the graph. So this completes the problem. Thank you.